Imagine you wake up one morning and something feels wrong. Therein, light pouring in through your window, but it did not soft like usual. It sharp, blinding, almost buzzing with heat. You step outside and your skin starts to burn. Not in the sunburn way, but as if someone pointed a space heater the size of a skyscraper directly at your face. You look up and the sun is no longer there. Something else has taken its place. Much bigger, much brighter, much worse. A supergiant star. And whether we chose to replace the sun or it just happened, one thing is instantly obvious. We are in serious trouble. Let's begin with what a supergiant star actually is. You may know our current sun is kind of average. In fact, it's a middle-sized, middle-aged yellow dwarf. Nothing too big, nothing too small. Now swap it out for something 10 to 100 times larger in mass, and often literally 1,000 times bigger in diameter. That's a supergiant star. There are red ones cooler, but massive and bloated, and blue ones, hotter, brighter, and burning through fuel like explosions in slow mode. These aren't stars, they cosmic mons. And now, you've got one sitting at the heart of our solar system, except sitting, it's quite right. Because the first thing it does is reach out and destroy everything. The red supergiant known as Betelgeuse, for example, is so large that if you placed it where the sun is right now, it would extend far beyond the orbit of Mars. That means Mercury, Venus, Earth, and Mars. Gone. We not talking about sudden scorching heat, we talking about your entire planet being inside the star. Melted, vaporized, absorbed without ceremony. In this version of events, you don't even have time to ask questions. The moment the sun is replaced, we are inside the expanding belly of a dying star. But let's get Jen, that to say we somehow saw it coming, and humanity found a way to move Earth far enough away to avoid vaporization. What would life be like then? First, we need to move Earth tens, maybe hundreds of millions of kilometers outward, far beyond our current orbit. Why? Because a supergiant star gives off hundreds of thousands of times more energy than our current sun. Staying where we are now would mean burning in a glare that could boil the oceans in minutes. So we reposition ourselves somewhere near where Jupiter is now. Out here, temperatures stabilize for a while, but the sky that tan forever changed. Step outside during the day, and your sky is no longer dominated by a bright disk. It's dominated by a wall of light. This new star is so huge and close in the sky that it doesn't rise and set. It simply hangs there, taking up most of your field of view like a second sky. You would be able to see other stars clearly at night because the light bleeding off this thing never really goes away. Darkness becomes rare, shadows become distorted, everything either glowing or scorched, and the effects don't stop at your eyes. This kind of constant intensity would mess with everything from plant life to circadian rhythms. Animals would be disoriented, sleep cycles would be broken, crops might need artificial darkness just to know when to grow. And if you felt uncomfortable under today's climate change, try handling a planet that has to invent new seasons just to survive starlight. Let's say you adapt, build shielded cities, underground farms, artificial light sites. You develop entire industries just to survive the day. You'd better move fast because there is a countdown tick. Supergiants aren't like our mellow sun. They don't live for long, while a star like the sun lasts for around 10 billion years. They burn through their fuel like a rocket engine left running with no pilot. Their outer layers churn and pulse. Fusion flares uncontrollably in deeper and deeper shells inside. Their cores are preparing for collapse, and one day, way too soon for comfort, that supergiant ends its short and dramatic life with a bang, a supernova. If Earth is nearby when that happens, even dozens or hundreds of light years away, the blast alone could cook the atmosphere, wipe out life, and tear through the solar system like a shotgun blast made of pure radiation. But we'd not dozens of light years away. We're right next to it. We'd be erased in the first millisecond. There would even be time to register what just happened, that and how violently these stars die. And what's left? Maybe a neutron star. Something so dense a teaspoon weighs a mountain or worse. A black hole quietly swallowing the remnants of a solar system that didn't stand a chance. Hard to imagine Earth ever recovering from that. But let's say you're not on Earth. Let us say you're some distant alien species. You point your telescope toward this shiny, unfamiliar sky and observe a system now dominated by one of the brightest stars in the galaxy. You see the planets orbiting it, if they haven't escaped already. To you it's a beautiful cosmic event, but to us it was home. So, could this ever happen in reality? Could the sun transform or be replaced by a supergiant star? In short, no, our sun simply doesn't have the mass, even if it burns for another few billion years. if it never reached the true super category. Instead, it will fade into a white dwarf, cooling silently for quadrillions of years. To get a supergiant, you need a star to start off at least 10 times more massive than the Sun, if not more. So, no, the Sun won't suddenly become Betelgeuse. But what if someone put one there, some godlike alien construction effort, or a cosmic accident we don't understand? Suddenly we forced to adapt to these harsh, massive conditions. Or pair could remove the Earth far enough. Could our technology keep pace? Or would we learn, maybe too late? What happens when you underestimate the power of colossal stars? With that much heat, mass, light, and time pressure? Probably not. But maybe, just before the flash, just before everything is ripped apart, someone would look up one last time and say, we should have kept our little yellow star. It wouldn't fly, but it never tried to kill us.